In this video, we're going to talk about linear and rational equations. So, a linear equation in one variable is an equation that can be written in the form a number times x plus or minus a number equals 0. Where a and b are just a number, and so that it stays a equation or some kind of linear equation, a cannot be 0. Right? A can be any other number. For example, 5x plus 20 equals 0. That's an example of a linear equation. Okay. What does it mean for us to solve an equation? Well, solving an equation in x involves determining all the values of x that result in a true statement when you substitute it in for x. Like what number can you plug in for x that would make this true? In this case, multiply by 5, add 20, and then equal 0. At the end, our final equivalent equation should be in the form of x equals a number, right? X equals whatever the number is that we figured out, the solution. So let's solve this equation, 5x plus 20 equals 0 for x. Notice how if there were more variables, we would need to still do the same algebra, but we're trying to solve for x. We're targeting out the variable x. So the solution would be the following. So 5x plus 20 equals 0. We begin by isolating things that have nothing to do with x or don't have the variable that we're solving for in mind. So move the 20 to the other side. We'll have 5x equals to negative 20. Since 5 and x are being multiplied, we're going to divide both sides by 5, or whatever number is being multiplied to the variable. 5 over 5 becomes a 1, so we have x is equals to negative 20 divided by 5, meaning x equals negative 4. Therefore, that is the solution, right? That's the number that if you were to plug it back in, it would give us a true statement. So what are the solving steps? What are the steps for solving a linear equation? These are the steps. So first thing that we want to do is simplify on each side by removing grouping symbols and combining like terms, meaning anything that's in parentheses, or if you have multiples of the same kind, then you want to group them together. Step 2 is to collect all the variable terms on one side and all of the number or constants on the other side. Step 3, isolate the variable and solve. Number 4 is uncommon, right? A lot of people don't check their work, but the idea here is to plug in what you think is the solution to double check and see if it actually gives us a true statement or satisfies the original equation. The next thing that we want to talk about is linear equations with fractions. So anything that has fractions tends to scare a lot of people, but let's try to get this idea down and it'll help us become better equation solvers, if you will. So the idea here is to begin by multiplying both sides of the equation by the least common denominator of any fractions in the equation. So the least common denominator, or LCD, is the smallest number that all denominators will divide into. Okay, so here's an example. We have the equation x plus 2 divided by 4. minus x minus 1 over 3. All of that is equals to 2. So first problem that we have with fractions, and we don't want to work with fractions, right? So the idea here is to get rid of them. My denominator is 4 and 3, so we want to figure out a number that is divisible by both 3 and 4. So a lot of times you can just multiply the numbers together and use that product. So for us, 4 times 3 would be 12, and that is actually the lowest common denominator between them. So here is the solution to that. So let's begin by multiplying everything by 12. So x plus 2 over 4 times 12 minus 12 times x minus 1 over 3 equals to 12 times 2. So everything on the left and everything on the right side has to be multiplied by the same number. It doesn't matter what number, you just have to be consistent. So now that we're multiplying everything by 12, we can go about it different ways, but the idea is that 4 goes into 12 how many times? Well, 3 times. So 3 times x plus 2 minus 3 goes into 12 how many times? 4 times. And this is one way to simplify the equation so it no longer has fractions. Okay? Then we're going to move on to distribute. So we'll have 3x plus 6 minus 4x minus 4. But actually, here's a problem. This is negative 4. So every time you multiply here, you're thinking times negative 4 times negative 4. Therefore, this right here is going to be positive 4, and this is equals to 24. Okay? At this point, we're combining like terms. So we'll have 3x minus 4x equals to 24, and we can move the 6 and the 4 to the other side, and we have negative x is equals to 14, but because we don't want a negative x, we want positive x, we can either multiply both sides by negative 1 or divide by negative 1 to get rid of that negative in front of the x. So the final answer is going to be x is equals to 14, or negative 14. And just to double check, we would need to plug it into the original and see if that's actually the correct solution. So let's do that. Negative 14 plus 2 over 4 minus negative 14 minus 1 over 3, and you're wondering, is that equals to 2? So negative 14 plus 2 is negative 12 over 4 minus negative 15 over 3. Negative 12 over 4 is the same thing as negative 3. And negative 3 minus negative 5, is that equal to 2? Negative 3 plus 5 becomes 2. And it's a true statement. The next thing that we want to talk about is rational equations. Same as before, right? It's just equations that have fractions in them. But in this case, we want to extend the idea to having variables in the denominator. So a rational equation is an equation containing one or more rational expressions. So this is a rational expression, a ratio, or a fraction. This is also a rational equation. Anything that has fractions is going to be considered a rational expression or equation. And the procedure to solve still involves multiplying each side by the least common denominator. But now that we're introducing the scenario where there's a variable in the denominator, there is something to consider. We must avoid any values of the variable that make a denominator equal 0. So in this example, we have 1 over x equals 1 over 5 plus 3 over 2x. Well, in the first fraction or the first ratio, the denominator would equal 0 if x is equals to 0, right? Because x is the only thing that's underneath. Well, if it were to equal 0, then we couldn't divide. We just cannot divide by 0. Then the term 3 over 2x, that denominator would equal 0 if x were 0, because 2 times 0 is 0, right? So we see that in both cases, by coincidence, x cannot equal 0, right? So that's one value that we have to avoid as we find the solutions. As we reach the end of the problem, we would want to figure out what are the values that x is equals to, and then exclude 0. So let's go ahead and solve this problem. And before we do anything, we'll just say, since we just talked about this problem, we'll say x equals 0 is a restrictive value. Okay, so before we do anything else, we have to write out what are the restrictive values for this problem. And it's just saying what are the values of x that we need to avoid. So 0 is one of them, and then now we're free to solve the problem. So just like we did before, we need to look at the numbers that are underneath, or even just the values. Here is x, here is 5, and here is 2x. So now, instead of figuring out just a number that all of those three things would divide into, we need to figure out an expression, because now it has to include some value of x. And so 1, 5, and 2 all have as their lowest common denominator 10. And then we just have to add a x to it. So here's what we're doing. We're multiplying everything by 10x. Okay, so this is what the problem looks like now that we're multiplying by the lowest common denominator. And the idea is that this and that x cancel out only. So therefore you have 10 is equals to the 5 goes into a 10 twice. So you are left with 2x times 1, which is 2x, plus, and then here we have x and x cancel each other. 2 goes into 2 once, 2 goes into 10 5 times. So therefore we'll have 5 times 3, which becomes 15, right? And so, let's not lose track of what we're solving for. We're still solving for x. So we'll move this 15 to the other side. And so we have negative 5 equals to 2x. And if we divide both sides by 2, we have that x is equals to negative 5 over 2. And as long as that solution doesn't equal 0, we're good, right? The restricted value and the final solution should not match. And if they did, then we would say no solution. But in this case, they didn't match. So we're good to go. That is the solution for that problem. Now, let's talk about types of equations. So you were given an equation and you solve it and you do your best to solve it. But there are 3 possible scenarios for the solution. And the first one would be that an equation that is true for all real numbers for which both sides are defined is called an identity, meaning that whatever you plug in for x happens to be in both sides, so you just replace that number and the left side equals the right side. I mean, it's as simple as that. The solution set to this equation is the set of all real numbers, right? So any number that you plug in here, it's a solution. Done. The second type is an equation that is true for at least one real number, and that's called a conditional equation, or one of the most commons, where it only has one solution. For example, 2x plus 3 equals 17. So there is one number that you multiply by 2 at 3 ends up equaling 17, right? That's what this is saying. So there's a condition, right? The condition is that whenever that number is the right number, you multiply by 2, you add 3, and then you get 17. And the last one is that there is an inconsistent type of equation. And that is an equation that is not true for even one real number. For example, x equals x plus 7. And so, since there is no number that is equal to itself plus 7, the equation has the solution set empty. The empty set, or no solution, right? There is no number that is equals to itself but 7 units larger, is what this is saying, right? So it will be a false statement. In summary, if x is equals to a real number, then we have a conditional equation, right? When the condition is met, the equation is true. The second type is when x is equals to all real numbers, or the identity, meaning that any number that you plug in works. Number 3 is going to be x equals no real numbers, or an inconsistent equation, or it has no solution. There is no number that you can plug in that's going to give you a true statement. That's what it's saying. I think that's everything for this video. Thank you for watching.